When you graph equations in Desmos, Desmos will point out very important points to you. These are things like x and y intercepts, high and low points on the graph. Let's use a parabola as an example. For instance, let's say we have the equation y equals x squared minus 6x plus 8. So here I have a parabola that's graphed. This parabola goes through the y-axis here and the x-axis down here on the x-axis, and then it also has a low point. And one thing you'll notice is that Desmos has put little gray points on each of these important points, and if I hover over those gray points, I will get the coordinate of that point. If I actually click on one, I will actually be able to see, and the point value will stay on the screen. Now, for us, x and y intercepts are going to be crucial in many areas of mathematics. The points I've highlighted here are x and y intercepts. In particular, the y-intercept of a graph is always where the graph crosses the y-axis. So 0, 8 is what we would call the y-intercept of the graph. The x-intercepts are where the graph crosses the x-axis, 2, 0, and 4, 0. These are important points for us. Now, Desmos will also point out other points which we'll get to later in the term. For instance, like this point at the very bottom of the graph, this is what we would consider a minimum. So sometimes it's also important to know where minimums are or maximums on a graph, and Desmos will also point those out to you. So here are 3 examples for you to try on your own. Go ahead and pause the video here and graph each of these 3 equations in Desmos and identify the x and y intercepts. Now remember, x and y intercepts are technically full points. They're an x and a y value for each. So make sure, just like you see in Desmos, when you click on those points, you write down the full point value for each x-intercept and each y-intercept. So go ahead and pause, then you can unpause, and if you need to, watch through my examples as I go through these, or you could just skip to the answers at the very end. So here we are in Desmos. Let's graph these 3 equations and identify their intercepts. Starting with y equals negative 2/3 x. Now to enter in a fraction, you can start with the numerator 2, and if you hit the slash for divide, it will automatically take you into the denominator for 3. Now, one thing you need to be aware of is that currently your cursor's in the denominator, so if I just type in x, see how it stays in the denominator? I do not want my x to be in the denominator if you look at my equation. So what you can do is either tab to get out of it, or just move your cursor so that you're outside of the fraction before you type in x. Plus 4. Here we have our line graph. Notice there are 2 gray spots where the graph crosses the x and y axis. If I click on the one on the x-axis, there's our x-intercept at 6, 0. If I click on the one on our y-axis, that would be the y-intercept of 0, 4. We can zoom out just to double check that there are no other x and y intercepts. Yep, the graph only has the one of each, so that is our answer to that problem. All right, let's just go back to the home screen and type in the next equation. Y equals x squared minus 4x minus 5. I'm going to move this graph up just a tad. So here it looks like we've got a parabola. If I click on the graph, we can see the gray points showing up again. On the x-axis, we have 2 points. One at 5, 0, and one at negative 1, 0. Those will be the x-intercepts because the graph is crossing the x-axis there. On the y-axis, we have the graph crossing at 0, negative 5, so that is the y-intercept. So those are our x and y-intercepts for this graph. All right, let's look at our next one. I'll go back to the default screen. Y equals negative x cubed minus x squared plus 2x. So here's our third equation. What we see is a little bit more involved graph. And in fact, if I zoom in, we can even see those intercepts even better. It looks like we're crossing the x-axis 3 times. Starting on the left, we have a point at negative 2, 0. In the middle, we are crossing at the origin at 0, 0. and on the right we're crossing at 1, 0. So we have 3 x-intercepts. We can zoom out just to double check. It looks like we don't have any other places where we cross the x-axis. So we have 3 x-intercepts. Oops, I zoomed in just a little too far. Let's go back to here. When we look at the y-axis, we are crossing at a single spot, and that was actually coincidentally one of the x-intercepts. Whenever you cross the origin, you have a point that is not only an x-intercept, but a y-intercept. So we have the origin as both an x and a y-intercept. So here we have the answers all in one place. There were 3 equations that we graphed in Desmos and then found the x and y intercepts for. So the first one was a line, the second one was a parabola, and then the third one was a cubic graph. In this case, they all had exactly one y-intercept, but graphs can have more than one x-intercept, and we saw that with the last 2 examples.